Okay, so we're going to be graphing the equation f of theta equals 2 sine 3 theta, and the first thing you want to do when you're graphing this, you want to find your amplitude, and that's going to be the absolute value of the a value in this equation. So the 2 is sitting in the a position, and so it's just going to be a positive 2. And so then you want to find your midline, and so since they're, you want to look to your d part of the equation, and since there is nothing there, it's understood that it's a plus 0, so your midline is going to be at 0. And so then to find your period, you want to use the formula 2 pi over absolute value of b, and so take your 2 pi and look over to your b, and the 3 is sitting there, so it's just going to be a 2 pi over 3. And since this is an easier equation, we're not going to have a phase shift, so you don't have to worry about that right now. So then to find the points that you're going to plot, you can just plug 90, 180, and 270 into your equation where the theta is. And so when you plug 90 in, you get a 0. When you plug 180 in, you get a pi. And when you plug 270 in, you get a 2 pi. And so you go over to your graph and you plot the 0 right there at the origin. Then you go up here and you plot where your next point is, and then you go down here where the amplitude is, and then up here, and I'll do a dashed line to show you not to go past the amplitude, and a dashed line on the midline. And so you just go up and down, up, and yeah, just there we go. And yeah.
Okay, so first we're going to find our midline, which is going to be D. So our midline here is 2. So then we graph our midline as 2 here. Then we're going to find our amplitude, which is the distance from the midline, which is A. So that's going to be 3. So you go 3 above your midline, 1, 3, and then 3 under your midline, which is going to be -1. And then you're going to find your period, which is 2 pi over b, and b is 1, so our period is just going to be 2 pi. And our phase shift is going to be the whatever's added or subtracted to the theta, in which we don't have anything in parentheses. Our phase shift is going to be 0. So then we're going to make our table with 3. So this is going to be our origin, spelled wrong. And this is going to be our period over 2, and this is going to be our period. So our period is 2 pi, so our period over 2 is going to be pi. So these are all our zeros, since this is a sine graph. So we're going to graph our zeros at the origin, at pi, and at 2 pi. And then we're going to go between both of these and put one up on the high midline, amplitude, and then put one down at the low one, and then follow the dots, like that.
Okay, to find sine of 2 theta minus pi, you're going to first want to find your amplitude, period, midline, and phase shift. So to find your amplitude, you're going to want to find b, which is the number that's going to be multiplied by your theta. So our amplitude is 2. And then to find our midline, you're going to want to find your c, but because there is no number for c, we can assume it's 0. So midline equals y equals 0. To find our period, you're going to want to do your 2 pi over b, so 2 pi over 2, which is our b, equals pi, so period equals pi. And to find our phase shift, it's going to be a lot easier to find it using a table. So what I've written here is you're going to first want to do 2 theta minus pi equals 0, which will ultimately we become theta equals pi over 2, which is our phase shift, which I've written here. So now you're going to want to add 1 to each of your numerator. So this becomes 2 pi over 2, which is ultimately pi, and then 3 pi over 2, which is on the graph. So I've plotted pi over 2, pi, and 3 pi over 2, and then we can assume that the next one is going to be 2 pi. To find our min and max, you're going to want to use your amplitude, which is 2. So our max is 2, our min is -2, max 2, -2. And then you can plot your points.
So first you can look at the equation and see the 2 in front. The 2 is the amplitude, so you can write 2 right there. Second, you can look at the end, and that's plus 3, and that's the midline, so it's y equals 3. And then to find the period, you'll divide 2 pi by whatever's being done to theta, which is 2 over 3, and that equals 3 when you put it in your calculator. And so then you make a chart. You can write 3 there, and my pen's running out of ink. You write 3 there, and then you can write this, that's the period, half of the period, which is 3 over 2, or 1 and 1/2, and then 0 is the origin. Next you need to find the phase shift, which is whatever's in the parentheses equal to 0, so that's 0 equals 2 over 3 theta minus 3 pi over 2. So you can add 3 pi over 2 to each side of the equation, and so you'll get 3 pi over 2 equals 2 over 2 theta over that. And then you can multiply by 3 each side, which would be 9 over 2 pi equals 2 theta, and then you need to divide it by 2. So that divided by 2 is equal to, so it's 9 over 2 divided by 2 equals 9 over 4. So your phase shift is 9 pi over 4. And then you would add this to each of your periods. So that would just be 9 over 4.
Oh, it's for problem.
This is 3 over 2 plus 9 over 4 equals 15 over 4. And this is 3 and 9 over 4, which is equal.
Okay, so you would plot your first period point, or at your origin, it would be 9 over 4 pi, or 2 1/4, so you would plot that here. And then the next one would be 15 pi over 4, or 3 3/4 pi, which you could plot right here at the bottom of your amplitude, which is at 1. And then you would plot 3 9/4 pi, which is also equal to 5 1/4 pi, which is right about here. So then you would just connect your points, and it would make that.